Hey there, Math 1. Today we are doing the next section in Chapter 7. We are going to continue with some different pairs of angles. We just got finished learning about vertical angles and a linear pair of angles and supplementary and complementary. And today we go over angles made by two lines crossed by a transversal. So here we go. You can see our goal today is to identify special pairs of angles that are made when two parallel lines are crossed by a transversal, and we're going to use properties to determine their measures. So, first of all, we want to know, what is a transversal? A transversal is a line. It intersects two or more other lines at distinct points. That means at different points. It doesn't intersect two other lines at the same point. When this happens, a total of 8 angles are formed, and they are split into 2 groups. And we are going to look at those 2 groups. Let me name the angles. So you have 4 angles up there, and then you have 4 angles down here, a total of 8 angles. Some of these angles are called interior angles, and some are called exterior angles. Interior angles are angles that are between the 2 lines. So that would be angles that are in here. These would be interior angles. So the angles that are interior angles are angle 3, 4, 5, and 6. And then on the other hand, angles that are exterior angles are angles that are outside the 2 lines. So that might be angles in these areas, right? Those would be your exterior angles. That would be angle 1, angle 2, angle 7, and angle 8. Right? Interior means inside, exterior means outside, and that is the 2 groups of angles we have so far. Now, when the 2 lines that the transversal crosses are parallel, things get even more interesting. There are actually 3 special, it's a terrible, right, of angles that we want to look at and understand. And they are listed down here. All right, so our first special pair is called alternate interior angles. Alternate interior angles. All right, these angles are both interior, right? One of them must be on each side of the transversal. That's what it means to be alternate. Alternate means they're on each side or opposite sides of the transversal. And you need 1 angle at each vertex, right? There's a vertex here, and there's a vertex here. And there's 4 angles at each vertex, right? Angle 3, 6, 7, and 8 are at the top vertex, and angle 1, 2, 4, and 5 are at the bottom vertex. So on these pairs of angles, we are talking about interior angles, and we need 1 of them on each side. So there are 2 pairs here. That would be angle 3, angle 4 would be 1 pair, right? Those are a pair of alternate interior angles. They're both interior and they're on opposite sides of the transversal. And then, of course, the other pair would be angle 5 and angle 6. So those are your alternate interior angles. And when the two lines that the transversal crosses are parallel, only when they're parallel, then the alternate interior angles have equal measures. So angle 3 and angle 4 equal each other. Angle 5 and angle 6 equal each other. By the way, do we know what this little symbol means? This little symbol means parallel. So when two lines have that little arrowhead, it means they're parallel to each other. All right, this brings us to our second pair. Our second pair are called same side interior angles. I like the little angle symbol there with the apostrophe S. All right, these angles, again, are both interior, but this time they're both on the same side of the transversal. So in this case, we are talking about these two angles, both interior, both on the same side of the transversal, and of course, one of them at each vertex. So we're talking about angle 3, angle 5, and angle 6, angle 4 would be the other pair of same side interior angles. And when the two lines that the transversal crosses are parallel, then the same side interior angles measures are supplementary, which means they add up to 180, right? So angle 3 and angle 5 add up to 180, and angle 6 and angle 4 add up to 180. And let's look at our last one. So our last ones are called corresponding angles. All right, so these are the most confusing, but they hopefully will become quite obvious to you. These angles have one interior and one exterior. They're on the same side of the transversal. And this is the confusing part. They sit in the same spot with respect to their line that the transversal crosses. Like they're both either above it or below it. So an example of this would be angle 7 and angle 5, right? They're both on the same side of the transversal, and they're both above their parallel line. So angle 7, angle 5. And another one would be, let me use a different color. You probably don't need to write them all. Well, you should write them all down. You don't need to mark them all like I am. Another one might be angle 3 and angle 2. All right, they're both on the left side of the transversal, and they're both below their parallel line. And then, of course, we could go to the other side and say angle 8 and angle 4. And last up, I guess we could go to angle 6 and angle 1. All of those pairs would be corresponding angles. And when the two lines that the transversal crosses are parallel,
the corresponding angles have equal measures.
Okay, those are our three big pairs of the days. Let's practice those just a little bit. All right, so example 1 says, using the figure at the right, name each of the following. Notice, by the way, that these two lines, M and N, not parallel. So these pairs of angles still exist, even if the lines are not parallel. We just don't know anything about their angle measures if the lines are not parallel. All right? All right, so corresponding angles. Can you name some corresponding angles? Well, that would be angle 1 and 3. Right? They are both to the left of their lines and above the transversal. How about another pair? Angle 2 and angle 4. That would be another pair. See how I did those with 2 lines instead of 1? And then we could go below the transversal, and we'd have angle 8 and angle 6. That would be those two. And then we could have gone 7 and 5, although I didn't ask for the last pair, but boom, there it is. Can you name all of the exterior angles? That would be the angles outside the 2 lines. Well, hopefully you can. The goal here is for you to name them actually before I name them, right? So that would be like angle 1, angle 8, angle 4, and angle 5. How about, can you name the alternate interior angles? So we want to go interior, that'd be between the lines, and on alternate sides of the transversal, that would be angle 2 and angle 6, right? Those guys would be alternate interior angles, and the other would be angle 3 and angle 7. All right? How about, well, this should be easy, same side interior. So again, we're interior, which is inside the 2 lines, but this time we're on the same side of the transversal. So that would be angle 2 and angle 3, or angle 7 and angle 6. All right. Now I did this one because it is not one of our pairs that we learn about, but you should be able to name it based on the words. All right. What does alternate mean? Alternate means opposite sides of the transversal, and exterior means outside the 2 lines. So an example of that would be, let's see, the exterior are out here and out here, right? So like angle 1 and angle 5 would be alternate exterior. They're both exterior, and they're on opposite sides of the transversal. And then the other would be angle 4 and angle 8. And I do want to point out to you that even though these pairs down here do not require all 3 lines, they only require 2 lines, they are still in the diagram. Can you name 3 pairs of vertical angles? Well, sure we can, right? Hopefully. 1 and 7 would be a pair of vertical angles. Or 2 and 8. Oops. Or 3 and 5. Right? Do you still recognize vertical angles? And even more importantly, do you still recognize a linear pair? Oops. So a linear pair, there are bunches of linear pairs here, right? The key thing about a linear pair that students have trouble with is a linear pair has to have the same vertex. Often I get students that think angle 2 and angle 3, since they make this line, they are a linear pair. But they are not, because they don't have the same vertex. I need 2 angles that are both at that same vertex, like angle 1, angle 2. angle 2, angle 7. These are angles that have the same vertex. They sit next to each other, and they make a line. Hence, a linear pair or a linear pair. I could keep going around the circle. Angle 7, angle 8, angle 8, angle 1. I've just named all the linear pairs going around that circle. And then I could go to the other vertex, and I could say angle 3, angle 4. Right? Linear pair, they get used quite often. Get used to them. All right, this brings us to our examples, and we will call it a day. In these examples, you'll notice the lines are parallel, and you are supposed to use the relationships that you have just learned to solve for the variable x. So the first thing you'd want to recognize here is what type of angles are these? Well, these two angles are same side interior. And so what is the relationship you know? Well, from the front of the notes, you know that same side interior angles add up to 180. So 5x minus 23 plus 7x minus 1 equals 180. I know we could all solve that if we wanted to. Do you want me to give you the answer? It's not that big a deal to me. I guess we'll just do this one. So that would be 12x minus 24. And I would add 24 to both sides. And I would divide by 12, which is 17, I think. X equals 17. All right, over here, these two angles, what type are they? They're the most confusing. Do you remember? They are corresponding angles. Right? And so on the front, we learned that when you have corresponding angles between parallel lines, they are equal to each other. So I could solve for x by setting those amounts equal to each other. Well, that's an easy one. Subtract 5x, add 1, x equals 29. By the way, then I could take that and I could put it in for x, and I could figure out exactly how big that angle is. All right, last two. All right, so this third example is interesting. These two angles are actually same side exterior. Now, we don't have a rule for same side exterior, but we could easily figure it out. And we would do it like this. These two angles here do have a rule. These two angles are equal to each other because they are corresponding angles. So because these are corresponding, they're equal, I know this is 23. And I do have a rule for these two angles. Do you know what it is? I hope you do. They make a linear pair. So I now know that x plus 23 equals 180, and I can solve for x just by subtracting 23 from both sides, and x would be 157. So apparently, same side exterior add up to 180 when they're between parallel lines. And last up, I have this one. So I'm supposed to solve for both x and y. Well, first I would solve for x by figuring out what's the relationship between those two angles. And here's how I do it. I'd call this angle 1, and let's call this angle 2 just for the heck of it. Angle 1 equals angle 2 because they are vertical angles. So I know that angle 1 is also 7x plus 13. And then let's call this angle 3. Angle 1 equals angle 3 because they are corresponding angles. See how I'm using my new rules? And so I actually know that the original two angles are equal to each other.
So I now know, because this equals this, and this equals this, that 7x plus 13 must equal 9x minus 19. And I could solve that for x, right? I would get x equals 16. So what I would do then is I'd put the 16 back into this and figure out how big that angle is. It would be 9 times 16, which is, let's see, 144. And 144 minus 19 is 125. This angle is 125. Then I could figure out why, because these two angles make a linear pair. So 3y minus 17 plus 125 equals 180. And I could solve that for y. I'm not going to, though. That's it. You now know how to use all these special pairs of angles. Good luck on the homework, and I'll see you guys next time.